Sdn and DPI. Why did I actually choose this topic? I think right off the bat, when I started delving into Sdn as a concept, as a new architecture movement, even in the back of my mind, I asked myself, what role or what ramifications will a new Sdn and an Sdn-enabled network produce for security? How it's deployed, maybe the least and most trivial in the grand scheme of things when you consider how do you activate layer 4 through layer 7 services, for example, on a network that's been driven centrally, given automation and insight into the network, whether there's a bidirectional feedback communication mechanism between the elements and the controller itself or not, or just by general purpose DevOps movement type methodologies where you might be configuring things on a controller and pushing information down to a client or agent, if you will, that's willing to accept those commands and sets of configuration information so that they can be manipulated. Those elements themselves can be manipulated. And then, at first I don't think any of us really thought about it. Quickly, though, I think the question was answered in a lot of respects by virtue of the overlay network architecture itself. Meaning, by doing so, by creating overlay tunnels and logically abstracting the network, you've effectively built a multi-tenancy architecture that is abstracted from one another in the sense of virtual networks, which is a concept that is driven by SDN controllers and their ability to create virtual networks, meaning containers of users, groups, departments, companies or applications within companies, whatever, again, that are grouped logically and cannot interact with other logical groups. That in itself in a multi-tenancy data center seemed to solve a lot of those security or quiesce a lot of those security questions. However, one of the questions that remained in my mind, and I know we will be talking about this sooner rather than later, hence my choice of the topic in the first place, is the fact that given the intelligence we already have into the application layer, layer 7, understanding what applications could be potentially harmful to the network, could suck up network bandwidth and network resources, compute resources thereby as well. We have those in employ today. The question is, how does this play in a new architecture such as SDN? And are there benefits and what ramifications are there to using some of the methodologies that complement SDN, like network function virtualization itself, whereby all of a sudden what was once a dedicated device running deep packet inspection can now be deployed in a virtualized manner, no more complicated or no more involved than we would have done in the past or up till now on virtual machines. Literally spinning up an instance, wherever that instance may be, whether it's on a bare metal server, whether it is still a dedicated appliance or another alternative, a router perhaps, or some other dedicated function in the network that actually has a services intelligence, whether it's been built into hardware or whether it's been introduced via a services module of some sort to augment the functionality of said router or firewall or switch. So that's where the focus of this thesis, if you will, lies in the very, discussion itself. It's like, what are the ramifications of deep packet inspection, having that layer 4 through layer 7 intelligence, if you will, and the visibility it brings. What ramifications and potential benefits can we derive from having that visibility? There are inherent challenges, of course, with the visibility this type of investigation into application layer information brings. I mean, we got to consider, the controller itself, the analytics engines that are going to be handling and compiling or threading through all this information, for lack of better words, and then presenting that to a northbound API or making that into a cohesive policy for southbound API introduction into elements. So forwarding state is modified. And furthermore, what we now coin as maybe service chaining or some type of bundled offering in the future from a business portfolio type of perspective. Regardless, this is again a movement that's being driven by network function virtualization and the ability to steer traffic and policy enforced traffic that needs to be actually investigated. This could be a value-add service. This could be just a function of an SDN architecture itself, perhaps financial, whereby everything must be secured and all encryption and things must be abstracted from each other. The examples are numerous, but nevertheless, having network function virtualization as a component within SDN or complementing it as an architecture component, rather, allows us to direct all flows, any flow, or certain flows to, layer 4 through layer 7 intelligent elements, and they can be either legacy, if you will, dedicated devices, embedded devices, and also, of course, virtualized devices that lived on virtualized vRouter or vSwitch type hypervisor implementations and are served by them. All of these lend itself to the overlay. And some of the things specifically revolving around the last example, which is virtual deployments, makes the introduction of deep packet inspection much easier and much more cost effective when you're thinking about how to get this kind of intelligence into the network. Historically, this might have been a perimeter activity whereby we had appliances, for lack of better words, or embedded functionality in other functions like routers, firewalls, or load balancers, for example. But these would sit more on the perimeter of the network, or on the edge, or on the walled garden aspect, and that we've built a wall around our protected resources, and this is how we're going to fortify it. We're going to be using these specialized platforms, hopefully fast enough, hopefully operationally not too intensive enough that we can manage them in this fashion. All of a sudden, with virtualized deployments, you have this ability to spread IDP, intrusion detection and prevention services, as well as intrusion prevention services all over the place. And they can be done, again, historically on a dedicated appliance, or now in a virtualized manner. Juniper has such offerings in the form of Firefly, for example, but not to get specific into vendors at all in this particular discussion. This lends itself to easier operational expense and more specifically CapEx, or reduction thereof. I mean, we're talking about spinning up virtually little to no cost virtual machines that perform what may be called service functions to create a service instance in the network. And again, these can be physical or virtual. When you consider that ability to all of a sudden roll out DPI like you never could before in a cost-effective way in areas of the network that need it most, not the areas of the network that it's most cost-effective to do so, you have a very compelling business case to actually go forth and secure the network in a holistic manner. Now, couple that with the centralized and automated manner in which you can manage your network, and let's take an overlay network, for example. This would allow for you to have a very holistic and comprehensive view of the network, or the entire data center network, if you will, as a whole, not individual devices and what they see. This holds true for most any concept in an overlay network architecture, whereby no individual device perspective or perspective from their point of view is gospel. It's more or less a compilation of all the information that's received from elements throughout the network. IDP brings visibility into the network that allows you to understand at a more granular level what's actually going on, what applications are on the network in general. This is the first and foremost question that a lot of organizations probably can't answer, other than to a large degree one protocol or another, per se voice or web traffic. You get any more granular than that, they may not know or have a very good idea of the percentages of traffic elsewise. Whether we're talking email, general purpose trash traffic, garbage, bum traffic, or applications that are of less importance in certain organization perspectives, whether that be peer-to-peer or social media, what have you. The point is, a lot of organizations don't have that visibility. DPI, or deep packet inspection, into the header and the data part of a packet will allow for the movement towards greater visibility. And this is all tied back to a centralized piece, a controller, if you will, an intelligent controller with analytics on board. They can take metadata, not so much just from the more traditional elements like switches and routers and what they bring from a routing table perspective, but metadata regarding network application information, and there again, which applications are actually hogging the network and utilizing the most bandwidth and the most resources. So, given that information, and here lie some challenges, compiling that information into a useful form and presenting that information via northbound API, in my envisionment, towards some kind of cohesive network management system, but more appropriately maybe a security information and event manager. Well, if we can do that, then you can all of a sudden understand how the network's being used on a day-to-day basis and over time historically. What that gives you is the ability to introduce new revenue generating services that won't utilize the network because of things that you've seen in the past, meaning you find other ways to carve out the network to provide services, and certain value-add services, such as I mentioned before, including service chaining driven services like customers that will need security throughout, firewalling, stateful firewalling, intrusion detection and prevention, deep packet inspection along with that, load balancing. There's a few others that we could introduce. Most any function in the network can be virtualized, and that's the way things are going, including switches first and routers second. So with that ability, you now have the chance to introduce more revenue into an existing infrastructure. The underlay remaining virtually unchanged with the exception of any augments that need to take place for the purpose of sheer capacity growth. But nevertheless, the underlying underlay could remain as is, in the aspect that the overlay is going to have to scale to introduce new services, and the overlay is going to be the one that has the intelligence to know if certain new services are even possible. But here again, if they're not, there's going to be reasons why. One of those reasons might be physical underlay limitations. Those can be addressed again in the conventional way through hardware or software augmentation, whatever the problem may be.